This is lesson 1.6, fractions and elementary algebra. And before we get started, we're going to talk about prime numbers and what factors are. Factors are what it takes to get a number. So for example, 6. The factors of 6 are what it takes to get a 6 when you multiply. The factors of 12 are 6 and 2 and 3 and 4 and 12 and 1. So there's a whole bunch of different factors there. So whenever you are finding a number that divides evenly into like 12, that would be a factor of 12. So 6 goes into 12 twice, 3 goes into 12 4 times, 4 goes into 12 3 times. So those are all factors. When you multiply them together, you will get the number you started with. Now, prime factors, on the other hand, are a little bit different. They're still factors. They're still the numbers multiplied together to get 12, but they're prime numbers. Prime numbers are numbers where nothing else divides evenly into it. So like 8 is not a prime number because 4 goes into it as well as 2. 7, on the other hand, is a prime number because you can't multiply any two numbers together except 7 times 1 to get 7. So 7 is prime. 11 is prime. There's no number that goes evenly into 11. 13 is prime. It's not all odd numbers because there's a lot of odd numbers that are not prime, like 9. 3 goes into 9. 15 is an odd number, but 5 and 3 go into that. 19 is a prime number because there aren't any numbers, but 21, 7 and 3 both go into that, so it is not prime. So it isn't just odd numbers that are prime, it's a combination of, well, no even number is prime because 2 always goes into an even number. So that's one help, is all your prime numbers are going to be odd, but they're not all the odd numbers. So a prime factor is a factor of a number that's also prime. So 12. If we were to say, write the prime factors of 12, well, you could start by going, well, 4 times 3 is 12. But 4 is not a prime number, so we have to find its prime factors. We have to find out what numbers go into 4. So 2 times 2 times 3. So 2 times 2 is 4 times 3 is 12. All three of those numbers are prime numbers, and when you multiply them together, you get 12. I have 18. My numbers that go into 18, well, I've got 2 and 9, but 9 is not prime, so then I write its factors. So 2 times 3 is 6 times 3 is 18. Or 3 times 3 is 9 times 2 is 18. If I have something like 32, well, let's see, 16 times 2 is 32, but since 16 is not a prime number, we make that 8 times 2, and then we bring down this times 2. But 8's not a prime number, so we make it 4 times 2. So that's prime, and that's prime, but this 4 is not, so we make it 2 times 2. So the prime factors of 32 are 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That whole pile of 5 2's are the prime factors of 32. So when you write down factors, they're always going to multiply together to get your original number, and they're always going to be prime numbers. And this is where we do what's called the factor tree. And you might remember this from old math lessons that you did with grumpy old ladies as your math teacher. All right, so if we have a number of 630 and we want to find the factors, we first of all take our 630 and we do this, and we try to figure out, all right, what two numbers multiplied together give me 600 or give me 630? Well, 63 times 10. Is 63 a prime number? No. 7 and 9 go into it. Is 7 a prime number? Yes, so we circle it, meaning we're done. 9 is not a prime number, so we divide that down. And now I know that 3 and 3 are both prime numbers, so I circle them because I'm done. 10 is not prime. 5 and 2. Is 5 prime? Yes. Is 2 prime? Yes. So everything we circled there and we're done. 2 times 3 times 3 times 5 times 7. Notice how I put them in the right order. I've got 5 numbers, but I put them from smallest to largest. So if we take these 5 numbers, multiply them together, we'll get 630. So those are the prime factors of 630. One of the things they do as well is they will make this sometimes a 3 squared. Since there's 3 times 3 is 9, they'll just do that. I don't really care one way or the other of how you do that, but that's the way it works. So prime factoring is important when you're reducing fractions. So in example 3, it gives us 210 over 231, and they're asking us to reduce that. So what we're going to do is we're going to take the prime factors of 210 and the prime factors of 231, and this is where calculators come in handy. And you find two numbers multiplied together, they give you 210. 21 and 10. Are either one of those prime? No. 7 and 3 and 2 and 5. Are any of those prime? Yes, they're all 4 prime, so I'm going to do that and be done. Let's do 231. What goes into 231? Well, 3 goes into 231 77 times. Is 3 prime? Yes. Is 77 prime? 77. No, it's not, because, let's use my white. Because 11 and 7 give me 77. Now these are prime. Alright, so we had 210 over 231, but I'm going to write 210 using my product of primes. So I'm going to write it as 2 times 3 times 5 times 7 over my product of primes here, 3 times 7 times 11. So now what I have is I have a fraction, which is 210 over 231, written as a product of primes. And then I can cancel. Anything on top that shows up on the bottom, I can make go away. And now what I'm going to do is I'm going to take my numbers on the top and multiply them, and my numbers on the bottom and multiply them. There's only an 11 there. And I get 10 over 11. That is that reduced. 10 over 11 is 210 over 231 reduced. So even though this seems to take a lot of time, it works very, very well as far as being able to reduce fractions. And you'll use this in in algebra all the time as far as when you're reducing fractions and things like that.